This video is recorded to help my students to understand how to estimate population mean when sigma is low. The sample mean x bar is the best point estimate of population mean. We need to know that. Assumption: either the population is normally distributed or the sample size is greater than 30. If the problem not mention this, we assume this assumption is true. Now, the calculation one is we need to know how to calculate confidence interval. The formula used is here. The E is margin of error. Z alpha over 2 we explained before in other videos, which is the z-score such that the area on the right side of this z-score is alpha over 2. Then sigma is population standard deviation, n is the sample size. So after you calculate margin of error, then the confidence interval will be x bar minus e to x bar plus e, where x bar is the mean of the sample. The second calculation we need to do is estimate the sample size in order to obtain desired confidence interval and the margin of error. So actually this formula, you can derive it from this formula. If you solve n in this equation, you will get this formula. So these two formulas actually are the same thing. But the first formula, you calculate margin of error based on alpha, sigma, and n. This one is if you know the margin of error, then know the sigma and alpha, then you calculate the n. Okay, let's see an example. A laboratory tested 83 chicken eggs and found that the sample mean amount of cholesterol was 220 milligrams. Sigma, suppose, is 18.4. Now ask you find a 95% confidence interval for the mean amount of cholesterol for the population of eggs. So we first need to type in whatever we know. X bar is 220, alpha is equal 1 minus 0.95. Okay, sigma is 18.4. Those are something we know. Now, the n is 83. We know all those information. So we first calculate z alpha over 2. Z alpha over 2 is the z-score such that this tail any alpha over 2. So whatever on his left side will be 1 minus alpha over 2. So we use normal standard distribution inverse. The probability leader is 1 minus alpha over 2. Alpha is in K11, so minus K11 divided by 2. Okay, so then we calculate the E. E is the margin of error will equal Z alpha over 2, which is in K15, multiply sigma, which is in K12. Then divide by square root of n, which is in case 13. Okay, use this calculator E. Now, then we can calculate the confidence interval. The upper limit will be x bar plus E. X bar is in K9, no, K8, K10, plus E. E is in K16. Okay, then the upper limit. Now, then the lower limit is x bar, which is K10 minus K16. Okay, so I got the confidence interval. Next example. Using your work from part A, which number in the confidence interval describe the point estimate for the population mean? Which number describe the margin of errors? So this problem tests you this concept. If you only know the confidence interval, can you figure out point estimate and the margin of error? Let us copy over the confidence interval to here. This confidence interval is 223.96. Upper limit 223.96. 223.96. Okay. The lower limit, let us copy over, is 216.04. 216.04. Now, suppose you only know this. Can you figure out what is the point estimate? Now, if you look at this, point estimate is in the center of the confidence interval. So in this case, what I supposed to do? I suppose equal center of the confidence interval, you use upper limit, which is in K10, plus lower limit, K11, divided by 2. So 222, which exactly match at the beginning. The problem tell you match the concept we said that the sample mean is the point estimate of the population mean. Okay. Then margin of errors. Margin of error, you say the confidence interval, his total length is 2 times margin of error. So margin of error is the half of confidence interval length. So which is the high upper limit, which in K10, minus lower limit K11, then divide by 2. So that's your margin of errors. Of course, this margin of error are slightly different from our margin of error we calculated. No different. Okay, margin of error here is calculated is 3.958. So since we throw something away, so now this is 3.96 is exactly correct. Okay, this basically tells the student need to know if only give you confidence interval, the student need to be able to figure out the point estimate and the margin of error. The key concept is the point of estimate is in the center of the confidence interval, and the margin of error is half of the confidence interval's length. Last example. Suppose the laboratory researches which to decrease the margin of error to 3 milligrams while maintain the 95% confidence. What sample size of the eggs should be used? Now, this time we need to estimate the sample size. Now, for this case, we still type in what we know first. Alpha equal 1 minus 0.95, okay, which is 0.05. Then we need to do the sigma. Sigma is 18.4. We know from the problem. Then margin of error, okay, we should reduce to 3. Okay. Now we need to use this formula. Use this formula, we first need to calculate z alpha over 2. Z alpha over 2 again is normal distribution, standard distribution inverse 1 minus alpha over 2. Alpha is in K11 over 2. Okay, I got this score. Then this n just simply equal z score, which is in K15, multiply sigma, which is in K12, then divide by margin of error, which is in K13, then the whole thing I need squared. So this gives me I need 146 x. If you have any questions, please give me an email.